I made a breakout board for one of these ESP32 modules which have 30 pins, and it's called DevKit V1. I don't know if that's do it or doit. And there's a couple of different ESP32 modules. Some of them have more pins, like this V4. So for the 30 pin, I made this breakout board with some peripherals with today's sponsor PCBWay, because with the width of this module, it's kind of awkward to work with on a breadboard. You kind of need to have two separate breadboards side by side. So I just made this board where I can have a copy of those 30 pins that I can plug into, but also it's always convenient to have a few LEDs, a few push buttons and stuff like that you can easily jumper over for some quick testing. And none of these peripherals are directly connected to the module. For the 4 LEDs, I just have 4 header pins. So if I want to use the LEDs, I can just put a DuPont jumper over to whichever GPIO I want. And that gives more flexibility as well in case I need to avoid using certain GPIO. I didn't want to have to commit the wiring. Likewise, with the 4 push buttons, there's 4 headers for those that can hook up to inputs. And down here, I have 4 exposed copper pads for touch inputs. So if I put DuPont wires over to touch pins, I can use these as touch plates. And there's also 4 level shifters here with the commonly used FET transistor method. So there's 4 3.3 volt pins and 4 5 volt pins so that we can have the 3.3 volt over on the ESP. And if we want, we can hook up a 5 volt Arduino or something else. So that's bidirectional level shifting on hand. There's a convenient reset switch, some 3.3 and 5 volt and ground header pins to power various other things. And finally, there's 2 op-amp circuits where we have adjustable gain and also a single bias voltage adjust. So we could use those to bring analog signals into an analog input on the ESP, in which case we would make sure we adjust the bias and the gain so that it falls within the allowable analog voltage. Or if we're generating some sort of signal out of here, we can put it into an op-amp and send that somewhere else off board. Looking at the schematic, there's the 30-pin ESP32 module, a duplicate copy of all of those module pins, and here those capacitive touch pads are literally just a square of copper connected to a DuPont compatible header pin. So we just plug in a DuPont and jumper it over to a touch pin. For buttons, just have a ground path to a header so we can have a pull-up on an ESP pin and press a button to go to ground. The LEDs are tied to ground so we can give a logic high out of the ESP to turn on the LED. And here's the 5 volt to 3.3 volt FET-based level shifter. And for the 2 identical op-amp circuits, we have a virtual ground here. We bias it up appropriately so we can have the full swing of our analog signal. And we have the pot here to adjust the gain of the op-amp, so we can either amplify or attenuate this analog input. And the idea is to be able to make the signal fit within the ADC voltage range of the ESP if we are using this to feed a signal in. And because we do want to bias this signal up above ground, because the analog input can only go from ground up to a certain max, there's no DC block capacitor on the output because that would remove our level shifting. So this allows us to go straight to the ADC input with a signal between ground and some maximum. But if we're going to use this to send audio out of the ESP into some other off-board hardware, we may want to add a series capacitor similar to the input here to get rid of the DC offset outside this board. So none of these things are directly wired up to the module to give more flexibility, not constraining this, and just let us make use of the module a lot easier. And because these circuits are not connected to this and not committed to any function, we could also just use this part of it without the module as a quick LED or push button or op-amp circuit for some other project entirely that does not even need an ESP32. In order to just test out those peripherals, I made this simple sketch that can control the 4 LEDs with either the capacitive touch pins, the push buttons, or external signals coming via those level shifters. So we configure all those pins as needed. Then in the loop, the first thing we do is read in the capacitive touch pins. And to avoid false readings, which I was having a problem with, we read the pin a couple of times and we take the highest reading, because when you are touching one of these pins, the capacitive touch reading value heads down toward a minimum number. So in this case, when nothing is being touched, I may get a reading over 60 on the capacitive touch pins. But when I touch it, it goes below 35, so I chose that as a safe value for this circuit. It may change if I used a different board or a different wire to touch. So I just looked in the serial monitor and observed how this behaved. So by reading each capacitive pin a couple of times and just accepting the highest reading that we get, if there's a momentary drop below the 35 threshold and then it goes up above 35 again, it was most likely a false trigger, so we just take that highest value and filter out the momentary low and don't count it as a valid touch. So after we've read in all the capacitive pins, we'll then go and control each of the LEDs and turn them on if the capacitive touch pin reading is below the threshold of 35, or if we are pushing the button associated with that LED, or if we're getting a logic low on the level shifter pins. And that worked out well, so then the only thing left was to just hook up something to these op amps and make sure I could adjust the signal with the potentiometers, and now the board is ready to be put to use.